Liquid gas in catalytic converters is a serious automotive problem that occurs when unburned fuel enters the converter in liquid form rather than as properly combusted exhaust gases. This is a critical issue because liquid fuel can severely damage the catalytic converter's internal components, leading to expensive repairs and environmental compliance problems. The primary causes fall into three main categories. First, fuel system malfunctions are responsible for the majority of cases. Leaking fuel injectors account for 35% of all incidents. Second, engine management issues cause 30% of cases. Misfiring cylinders are a major contributor, along with faulty oxygen sensors that provide incorrect air-fuel mixture data to the engine control unit. Third, ignition system failures can also cause liquid fuel to reach the catalytic converter. Worn spark plugs and timing issues prevent proper combustion, allowing unburned fuel to pass through the exhaust system. When liquid fuel enters the catalytic converter, three critical damage processes occur. The substrate becomes contaminated. Thermal shock from rapid temperature changes can crack internal components, and catalyst poisoning deactivates the precious metals that make the converter work. Liquid fuel in catalytic converters creates three critical risks that can destroy the entire emission control system. First, substrate contamination occurs when liquid fuel coats the honeycomb structure, blocking the active catalyst sites and preventing proper exhaust treatment. Second, thermal shock happens when liquid fuel rapidly evaporates inside the converter, creating extreme temperature changes that crack the ceramic substrate. Third, catalyst poisoning permanently deactivates the precious metals like platinum and palladium, making the converter completely ineffective at reducing emissions. Modern vehicles use advanced diagnostic systems to detect these problems before complete failure occurs. The OBD3 system continuously monitors catalytic converter performance, detecting liquid fuel contamination through real-time exhaust analysis and temperature monitoring. These systems can identify contamination up to 60% faster than previous diagnostic tools, allowing for early intervention before expensive damage occurs. When contamination is detected, there are three levels of solutions, depending on the severity of the problem. Prevention is the most cost-effective approach, requiring only regular fuel system maintenance and using quality fuel to avoid contamination entirely. Early intervention involves fuel system cleaning and injector replacement when contamination is first detected, costing between $800 and $1,500. Complete failure requires converter replacement with full fuel system overhaul, costing between $1,200 and $3,500, highlighting why early detection is crucial. The cost difference between prevention and complete repair demonstrates why regular maintenance and early detection are essential for protecting your vehicle's emission control system.